45 years ago, two robotic explorers launched from Earth, carrying humanity's hopes into the cosmic unknown. These twin spacecraft would travel farther than any human-made object before them, revealing worlds so alien they defied every prediction scientists had made. We'll witness a moon that spits fire into space, rings that sing like cosmic wind chimes, and storms that could swallow our entire planet whole. We'll discover oceans hidden beneath miles of ice, winds that race at impossible speeds, and the very edge of our solar system itself. Don't forget to like and subscribe as we follow these incredible machines on their journey. Prepare yourselves. We begin. Voyager 1 approached Jupiter in March 1979. Its cameras focusing on a swirling red oval that astronomers had watched through telescopes for over 300 years. But nothing could have prepared scientists for what they were about to discover about this mysterious crimson mark floating in Jupiter's atmosphere. The Great Red Spot wasn't just a storm. It was a hurricane so massive that you could drop Earth inside it twice and still have room left over. As Voyager's instruments peered into this cosmic cyclone, they revealed wind speeds reaching 400 miles per hour, fast enough to circle our entire planet in just 6 hours. The storm's red color came from phosphorus compounds being churned up from deep within Jupiter's atmosphere, like cosmic blood rising to the surface. What shocked scientists most was the storm's age and stability. While hurricanes on Earth last for days or weeks before burning out, this Jovian monster had been raging for centuries without losing strength. Think of it like a spinning top that never stops, powered by Jupiter's internal heat and the planet's rapid rotation. The storm rotates counterclockwise, completing one full rotation every 6 Earth days, moving like a giant cosmic gear in Jupiter's atmospheric machine. Voyager's close-up images revealed intricate details within the storm that no telescope could capture. Smaller storms swirled around the Great Red Spot's edges like cosmic auroras following a whale, sometimes getting absorbed into the larger system. The storm's eye measured 12,000 meters across, wide enough to swallow our moon with room to spare. Temperature readings showed the storm center was actually colder than the surrounding atmosphere, creating a high-pressure system that acts like an atmospheric mountain floating in Jupiter's sky. But the most mind-bending discovery was yet to come. Scientists realized the Great Red Spot was actually shrinking. Historical observations showed it had been twice its current size just 100 years earlier. This cosmic hurricane was slowly dying, though it would likely survive for centuries more before finally disappearing into Jupiter's turbulent atmosphere. The storm's behavior defied everything meteorologists knew about weather systems. On Earth, hurricanes weaken when they move over land or cold water. But Jupiter has no solid surface to disrupt the flow. The Great Red Spot floats in an endless ocean of gas, drawing energy from the planet's core heat 400 million miles from the warming influence of our sun. As Voyager 1 transmitted these incredible images back to Earth, taking 18 months for the radio signals to reach mission control, scientists realized they were witnessing something unprecedented in human history. They were watching weather on an alien world, seeing storms that operated by rules completely different from anything in Earth's atmosphere. The data streaming back from Voyager revealed that Jupiter wasn't just a larger version of Earth. It was an entirely different kind of world where physics played by different rules. The Great Red Spot was just the beginning of discoveries that would revolutionize our understanding of planetary science. But compared to what Voyager would find orbiting this gas giant, even this Earth-sized storm would seem calm. Just days after Voyager 1 revealed Jupiter's secrets, it turned its cameras toward the planet's moons and discovered something that made every scientist on Earth question the laws of physics. Io, Jupiter's innermost large moon, was literally exploding before their eyes. Navigation engineer Linda Morabito was examining images for navigation purposes when she spotted something impossible. A crescent-shaped plume rising 300 meters above Io's surface. At first, mission controllers thought they were seeing a background star or a camera malfunction. But as more images arrived, the shocking truth became undeniable. Io was the most volcanically active world in our entire solar system. 8 active volcanic eruptions were visible in that first flyby, shooting sulfur and sulfur dioxide hundreds of miles into space. These weren't the gentle lava flows you might find in Hawaii. These were volcanic explosions so powerful they could launch material completely off the moon and into orbit around Jupiter. Imagine standing on a world where the ground beneath your feet constantly trembles and mountains regularly explode with the force of nuclear weapons. The volcanic plumes created umbrella-shaped clouds that spread across hundreds of miles before falling back to Io's surface like alien snow. Some eruptions reached temperatures of 3,000 degrees F, hot enough to melt copper instantly. The moon's surface changed so rapidly that features visible in one Voyager image had completely disappeared by the time Voyager 2 arrived 4 months later. But what was driving this incredible volcanic activity? Scientists discovered that Io was being constantly squeezed and stretched by Jupiter's immense gravity like a cosmic stress ball in the hands of a giant. As Io orbits Jupiter, the gravitational pull from Jupiter and its neighboring moons, Europa and Ganymede, creates tidal forces that flex the moon's interior. This constant kneading generates enough heat to keep Io's interior molten, creating a world-sized volcanic furnace. The surface of Io resembled a cosmic pizza painted in brilliant yellows, oranges, and reds from sulfur compounds. No impact craters were visible anywhere. The constant volcanic activity had erased every scar from space rocks, creating the youngest surface of any solid body in the solar system. Lava lakes bubbled and churned across the landscape, some larger than entire states on Earth. Voyager's instruments detected sulfur dioxide frost covering much of Io's surface, created when volcanic gases freeze in the moon's thin atmosphere. The volcanic plumes weren't just spectacular light shows. They were actively resurfacing the entire moon, burying the landscape under layers of fresh volcanic material every few thousand years. Think of Io as a cosmic construction site where the entire world gets rebuilt over and over again. The discovery of Io's volcanoes proved that moons weren't just dead airless rocks orbiting their planets. They could be dynamic, evolving worlds with their own weather systems and geological processes. This tiny moon, smaller than Earth's own satellite, was generating more volcanic activity than our entire planet. But hidden beneath the ice of Io's neighbor Europa, an even more astounding discovery was waiting to be revealed. While Io blazed with volcanic fury, its neighbor Europa appeared deceptively calm from Voyager's cameras. This ice-covered moon reflected sunlight like a cosmic mirror, showing a surface smoother than a billiard ball. But hidden beneath that pristine frozen shell lay a secret that would change how scientists searched for life in the universe. Europa's surface revealed a puzzle of cracks and ridges that stretched across its entire frozen landscape like a shattered eggshell. These weren't random fractures. They formed organized patterns that suggested something incredible was happening beneath the ice. The moon's surface showed almost no impact craters, meaning the ice was constantly renewed and resurfaced by some hidden mechanism. Scientists studying Voyager's data realized they were looking at the frozen surface of a global ocean. Beneath Europa's ice shell, which could be anywhere from 10 to 15 meters thick, lay an ocean containing twice as much water as all of Earth's oceans combined. This subsurface sea was kept liquid by the same tidal heating that powered Io's volcanoes. But instead of creating eruptions, the energy warmed a vast underground ocean. The ice shell wasn't static. It was constantly moving and reshaping itself like frozen pack ice on Earth's polar seas. Warm water from below caused the ice to expand and crack, creating the intricate pattern of ridges and valleys that covered Europa's surface. Some areas showed where the ice had pulled apart and creating features that looked like frozen rivers running across the moon's face. Think of Europa like a cosmic egg with a shell of ice instead of calcium carbonate. Crack that shell and you'd find not yolk, but an ocean deeper than any trench on Earth. This ocean was dark and cold, never touched by sunlight. But it was liquid water, the essential ingredient for life as we know it. Scientists began to wonder if this hidden sea might harbor living organisms in its depths. The implications were staggering. If Europa had a global ocean, it meant that habitable environments might exist throughout the outer solar system, far from the warming influence of the sun. Life might not need sunlight and moderate temperatures. It might thrive in the cold, dark depths of alien seas, drawing energy from chemical processes instead of photosynthesis. Voyager's discovery transformed Europa from just another ice-covered rock into one of the most intriguing worlds in our solar system. The smooth, youthful surface suggested the ocean below was actively connected to the surface ice, potentially allowing nutrients and chemicals to cycle between the sea and the frozen shell above. This meant Europa's ocean wasn't just a stagnant pool of water. It was a dynamic system that could support complex chemistry. The search for life beyond Earth had always focused on planets in the habitable zone where liquid water could exist on the surface. But Europa proved that habitable worlds might be hiding in the most unexpected places, wrapped in ice and orbiting giant planets hundreds of millions of miles from the Sun. As Voyager continued its journey towards Saturn, scientists knew they had discovered something extraordinary. An entire ocean world hidden beneath a deceptively simple surface of ice. But Saturn held even more surprises, starting with rings that weren't what anyone expected. When Voyager 1 approached Saturn in November 1980, astronomers thought they understood the planet's rings pretty well. Through telescopes, Saturn appeared to have a few distinct rings separated by dark gaps like grooves on a cosmic record album. But as Voyager cameras captured the ring system in unprecedented detail, scientists discovered they had been completely wrong about one of the solar system's most beautiful features. The rings weren't solid bands of material at all. They were made of countless individual chunks of ice and rock, each following its own orbit around Saturn, like a swarm of cosmic bees. Some pieces were as small as snowflakes, others as large as houses, all spinning and tumbling through space in a carefully choreographed gravitational dance that had been playing out for millions of years. What appeared as a few simple rings from Earth actually contained thousands of individual ringlets, each with its own orbital speed and characteristics. The ring system resembled a cosmic photograph record with grooves so fine they couldn't be resolved from Earth. Some gaps between rings were caused by tiny moons acting like cosmic shepherds using their gravity to sweep ring particles into organized lanes. Voyager discovered that Saturn's rings were incredibly thin compared to their vast diameter. While the main ring system stretched over 170,000 meters across, nearly half the distance from Earth to the Moon, the rings were typically only about 30 feet thick. Imagine a sheet of paper scaled up to the size of a football field, and you'd get an idea of how remarkably flat Saturn's rings really were. The ice particles in the rings sparkled like diamonds in sunlight, creating one of the most spectacular sights in the solar system. These weren't dirty chunks of rock. They were mostly pure water ice, probably formed when comets or small moons were torn apart by Saturn's powerful gravity. The largest pieces tumbled slowly as they orbited, creating a gentle cosmic snowstorm that had been falling for eons. But the biggest surprise came when Voyager discovered structures within the rings that seemed to defy physics. Some ringlets appeared braided together like cosmic rope, while others showed dark spokes that rotated with the rings despite having no apparent physical cause. These spokes appeared and disappeared like ghostly shadows moving across the ring plane, created by electromagnetic forces that charged tiny dust particles and lifted them above the main ring structure. Saturn's gravity wasn't the only force shaping the rings. The planet's magnetic field interacted with charged particles, creating waves and disturbances that propagated through the ring system like ripples on a pond. Small moons embedded within the rings carved gaps and maintained sharp edges through gravitational shuffering, while resonances with larger moons created spiral density waves that looked like frozen sonic booms. The ring system was incredibly dynamic, constantly changing as particles collided, stuck together, and broke apart again. What looked like a static, unchanging structure from Earth was actually a bustling ecosystem of ice and rock in constant motion. Scientists realized they were watching the birth and death of ring particles in real time, witnessing processes that had been shaping planetary ring systems for billions of years. These discoveries revolutionized understanding of how ring systems form and evolve, providing insights that would prove crucial for understanding similar structures around other planets throughout the universe. But hidden among Saturn's many moons, an even stranger world was waiting to reveal secrets that would rewrite the textbooks on planetary atmospheres. Among Saturn's 62 known moons, one stood out as completely unique even before Voyager arrived. Titan, Saturn's largest moon, was shrouded in a thick orange atmosphere that completely hid its surface from view. But when Voyager 1 flew past this mysterious world in November 1980, it discovered something that made scientists question everything they thought they knew about planetary atmospheres. Titan's atmosphere was thicker than Earth's, creating a surface pressure 1.5 times greater than what we experience at sea level. This made Titan the only moon in our solar system with a substantial atmosphere thick enough for a human to walk around without a pressure suit.